Do you ever wonder what it'd be like if you'd done something differently? If you'd moved somewhere else or took more risks?
Two paths diverge in the woods. Which one will I take?
For me, I've always wondered what my life would be like if I attended a different graduate school. I wouldn't have met my husband or started the outreach program that launched my Kate the Chemist career.
Maybe if I was a foot taller, maybe playing basketball, maybe I should be in the NBA playoffs.
Do you have any missed opportunities? Like a job you turned down or a relationship that got away? Do you ever think, what if I'd studied abroad or gone after my childhood dreams? What would my life look like now?
I always think about the version of myself that went to a South African school, and I think if I did that, I probably would have went to a South African college. I might be living in South Africa right now still, and I don't know if it would have been a better life. I think it just would have been very, very different.
According to the New York Times bestselling author Daniel Pink, humans have 4 core types of regrets: boldness, connection, foundation, and moral regrets. In his book, The Power of Regret, he offers strategies to help us make better decisions. Ideally, so that we spend less time ruminating on how our lives could be different and stop asking that painful question, what if? I mean, what's the point? It's not like we can ever really know what those versions of us ended up like, right? Well, what if I told you some scientists do think there are other versions of us? The many worlds interpretation is this theory that there are other iterations of us out there, replicants who have made different life choices than us, but are still us in some sense.
Peter!
Yeah? Oh, sorry.
Did you mean Peter Parker?
Same again, we're all Peter Parker.
That's right, y'all. Put your skeptic hat on, because for our last episode of the season, we're diving into something that feels more like Hollywood magic and less like peer-reviewed science. I'm gonna be honest with you, when my producers pitched this idea to me, I hated it. But they asked me to have an open mind, and I'm really glad that I did. From the Sowers Institute for Medical Research and KCUR Studios in Kansas City, this is Seeking a Scientist, a podcast where science fiction meets reality. I'm Dr. Kate Biberdorf, aka Kate the Chemist, and in this episode, we're getting to the bottom of this whole parallel universe idea.
What bothers me is that last night you were in my dream.
That wasn't a dream. It was another universe.
Okay, this is a quantum computer, right? We barely know how it works. It's basically magic.
What's a multiverse?
Get her out of here.
Hollywood has a lot of ideas of what the many worlds interpretation means, but what does the science say?
Way more than millions of you running around. They're not you any more than if you have an identical twin. It's a separate entity that used to be identical with you, but something happened, whether it's the zygote splitting or the universe splitting.
Will we ever be able to meet these different versions of ourselves? I mean, how do we even wrap our brains around this?
You shouldn't be trying to visualize them better. You should be trying to say to yourself, there are many, many universes. At the same time, that's it.
And what does our obsession with this theory say about us? You may have noticed a certain plot device popping up across sci-fi franchises lately. Multiverses, parallel universes, or the idea of many worlds stacked on each other. Movies like Spider-Man Across the Spider-Verse, Doctor Strange and the Multiverse of Madness, and Everything Everywhere All at Once have been exploding at box offices and gaining critical acclaim. These movies explore the idea that there may be another you, or even millions of other, yous, and worlds that resemble this one, but are just a little off. Parallel universes aren't just writer's room solutions to get characters from one studio's franchise to another. There's actually some scientific theory to it. In physics, the many worlds interpretation of quantum mechanics dates back to the late 1950s. This wacky but somewhat credible theory takes quantum physics to the next level. The idea is that at every fork in the road, your world splits into 2, and you continue about your day in your world, while you 2.0 moves about their entirely separate world. That is, until either of you reaches another junction, and then you split again and again and again until there are billions of your descendants running around in billions of different worlds.
Jeez Louise, how many of you are there?
And interestingly, Hollywood takes cues from real scientists to replicate multiverse theories in their movies. Let me introduce you to Professor Sean Carroll. He's a theoretical physicist and philosopher who specializes in quantum mechanics, cosmology, and the philosophy of science.
I used to live in Los Angeles, and I served as a consultant to a lot of movies and TV shows, one of which was the last two Avengers movies, Endgame and Infinity War. And so, spoiler alert for anyone who's not seen the movies, there's this event, right? The snap, where Thanos kills a lot of people.
Does it start? I don't feel so good.
You're all right.
I don't know what's happening. I don't know.
Real quick, Thanos is the big bad guy in the recent Marvel Studios and Avengers films. After his home on planet Titan collapses due to a lack of resources, he begins an altruistically demented crusade to prevent other planets from suffering a similar fate.
Titan was like most planets. Too many mouths, not enough to go around. And when we faced extinction, I offered a solution.
Genocide.
But Marvel Studios couldn't survive economically if they permanently killed off future franchise potential.
We're not going to let Doctor Strange and Black Panther remain dead. We want to make more movies with these people.
So what did they do? They tapped into the quantum realm, or parallel dimensions, that can be used to access different timelines and universes. And Sean is the perfect guy to consult on these big movies because he's the author of the popular book, Something Deeply Hidden, Quantum Worlds and the Emergence of Space-Time. His job is to poke holes in the plots of these films and attempt to make scripts as scientifically accurate as possible.
I consulted on the time travel bits a little bit, and, the line Ant-Man says, so you're telling me that Back to the Future is just bullshit, because I badmouthed Bad to the Future.
Anyone in Hollywood knows the number one rule. Be careful what you say in front of writers. Anything funny can and will make its way into the script. Do you know where your passion for physics came from? Like where it started?
Came from the universe. That's the only thing I can say. There was nowhere else that I can particularly pinpoint there. Sorry. I became interested in science pretty darn young. Yeah, I was around 10, and there was no one in my family or at my school who was especially science-y. I just started reading books and fell in love with it. Would hang out at the local public library in whatever section of the Dewey Decimal System corresponded to physics and, read about the Big Bang and particles and black holes. It was great.
So I want to get into some really complicated science when we chat about multiverses in a bit. But first, let's start with the basics. What is physics?
The jokey answer is that physics is everything and everything else is just a subset of physics, right? Chemistry and biology are just physics applied in different ways. But the slightly less jokey answer is that physics is the particular angle on what the universe is made of that looks at the most fundamental parts, right? It looks at particles and fields and gravity. Sometimes it looks at them in ways where they're collective behaviors. So there's material physics and plasma physics and atomic physics, but it's really about digging deep into what's going on underneath. Sometimes it's big things like cosmology or the Big Bang, but you really want to understand the basics, the essentials. And in practice, that means that there's lots of different kinds of physicists.
In short, physics is the study of energy and matter and how they interact with each other. Physicists study heat, radiation, magnetism, and mechanics, both here on Earth and on other planets. I like to explain it as physics is applied math, chemistry is applied physics, and astrophysics is just physics in space. But Sean adds another layer. Well, in your bio, it states that you're a physicist and a philosopher. Which one would you say came first?
Oh, physicist definitely came first. My whole life I've been a professional physicist, and it wasn't until when I was an undergraduate that I discovered philosophy at all, but it was always just an interest or a hobby. But now it's been 20 years that I started really understanding that there was a category of philosophers who worked in what is known as the foundations of physics, which is really a kind of physics that is just done in philosophy departments, honestly. The modern era of fundamental physics is moving much more slowly than it was 50 years ago. And there's different responses you can have to that. And my response is to take a step back and think about the philosophical or foundational underpinnings of the field. So I'm still chasing the same questions I've always chased. What is the universe? What is it made of? Where did it come from? But I'm doing that taking into account contributions from philosophy as well as from physics.
Early scientists were also philosophers. Greek philosopher Democritus was the first person to propose the idea of the atom back in the 5th century BCE. Another brilliant Greek philosopher came up with the idea of the 4 elements: earth, wind, air, and fire. But it was Aristotle that is often given credit for putting the finishing touches on the theory.
You know, it was Aristotle that first wrote a book with the title Physics. So he gets credit for sort of inventing that term, even though it was a subset of philosophy at the time.
The two fields, philosophy and science, began to split in the 16th century and truly separated in the 17th century during the Age of Enlightenment, when Isaac Newton first proposed the idea of classical mechanics using Aristotle's ideas.
And Aristotle had a view that is actually very natural. If you push something and then you stop pushing, it will come to rest. But it was put together by Isaac Newton in the 1600s in a magisterial system where he invented all the math and all the physics that you need to talk about this. And the answer is, if you tell me the position and the velocity of every part of the universe, and you tell me the forces of nature acting on all those different parts, I can predict exactly what the universe is going to do in perpetuity in the future. And that was the birth of classical mechanics.
So let's break down what he just said. Classical mechanics works really well for big objects, like a baseball or a car. We know that a ball will not throw itself or roll up a hill. Someone or something must apply a force to get it moving. And then we can predict its position, velocity, and acceleration using some really beautiful equations. But in the early 1900s, distinguished physicist Albert Einstein was shining lights on metals and scratching his head because classical mechanics was not explaining what he was seeing. This, my friends, is where quantum mechanics comes in, and that's how we enter the multiverse.
Because frankly, the multiverse is a concept about which we know frighteningly little.
The multiverse is real.
Y'all, to get into the origin of quantum mechanics, I've got to tell you about one of the biggest scientific battles of the 20th century. It involves a lot of opinionated scientists, and our pal Albert Einstein somehow ends up on the losing side. Let me set the scene. It's the early 1900s, and scientists are obsessed with studying the atom. They had just discovered the nucleus and the electron, and Niels Bohr was putting it all together in the first decent proposal for the structure of the atom. Now, let me be clear. Bohr's model is excellent. I teach it in my classroom every year. But unfortunately, it only works for atoms with one electron, and we only have one of those, hydrogen. As soon as we add a second or a third electron, the model breaks down. But Bohr's assistant, Werner Heisenberg, had an idea, which turned into the earliest understanding of how atomic particles exist and interact with each other.
He and some of his colleagues proposed the first really clear, clean version of quantum mechanics that was called matrix mechanics. And it made predictions, but it used mathematics that the field of physicists just weren't very familiar with. And, they were kind of reluctant to learn all this new math and whatever.
This new math supported the data, but it was really hard to do. A year later, a physicist named Erwin Schrödinger, remember that name, fine-tuned these complicated matrices and converted them into a wave function.
And he comes up with this alternative way of doing quantum mechanics based on waves. Physicists like waves. They knew how to do that, right? So physicists breathed a sigh of relief and go, oh, okay, good, that's our happy place.
But the scientific community wasn't satisfied with Schrödinger's equation by itself. So another physicist, Max Born, grandfather to Olivia Newton-John, did something insane. He took Schrodinger's equation and squared it.
So then Schrodinger is horrified by this. He's like, what have you done to my equation? He literally says, if I knew that was going to happen, I never would have gotten involved in the whole thing.
Regardless, Bohr and his colleagues postulated that physical entities have probabilities of existing without being in a specific position until they are observed. And since they lived in Copenhagen at the time, other scientists began to refer to this theory as the Copenhagen interpretation, probably because there are too many players involved and it's hard to keep everyone's name straight. Now, I'm going to jump out of chronological order here and zoom ahead to the 1930s because that's when Schrodinger had another stroke of genius. During a conversation with Albert Einstein, Schrodinger came up with a perfect analogy to help explain this confusing theory.
We might consider Schrodinger's cat.
Sheldon from The Big Bang Theory summarizes the experiment perfectly.
In 1935, Erwin Schrödinger, in an attempt to explain the Copenhagen interpretation of quantum physics, he proposed an experiment where a cat is placed in a box with a sealed vial of poison that will break open at a random time. Now, since no one knows when or if the poison has been released, until the box is opened, the cat can be thought of as both alive and dead.
In quantum mechanics, we use Schrodinger's cat as a thought experiment to explore the idea of quantum superposition. This tricky concept basically states that a particle can be in multiple states at a time until it is measured. So, that cat is simultaneously alive and dead until we measure it by opening up the box and looking inside, just like Bohr said.
That's very, very helpful in understanding many worlds. The Schrodinger's cat thought experiment was invented by Schrodinger, number one, because he didn't like cats, but number two, because he wanted to emphasize how weird quantum mechanics is. The point of Copenhagen quantum mechanics is the best way to think about it is it truly is both until you observe it.
It might be easy to think that Schrodinger was using his cat example to prove the Copenhagen interpretation, but the truth is it was the exact opposite.
And Schrodinger is saying, that's absurd. I don't believe that. You don't really believe that, do you? That there's really a superposition of both in the box.
So, back in the 1920s, two distinct cohorts of scientists emerged. On one side, we had Bohr, Born, and Heisenberg, who believed in the Copenhagen interpretation, that electrons exist in a number of different positions until they are observed. And on the other side, there were those who thought the theory was incomplete, mainly Schrodinger and Einstein. Here's how the series Genius dramatized Einstein's frustration.
And according to my esteemed colleague, Dr. Niels Bohr, the particle does not exist at all until we observe it.
That makes absolutely no sense to me.
Exactly. Thank you, Ernst.
It all came to head in 1927 at the Solvay Conference in Brussels when 29 scientists gathered to debate the theories of quantum physics. And get this, 17 of them were Nobel laureates. So these were the smartest people in the world having very lively discussions. And when I say that, I mean Einstein and Bohr got into a legendary intellectual do-si-do.
Niels, it defies common sense that the rules which govern those things we can see do not apply to those we cannot.
Bohr was hung up on probabilities, accusing Einstein of being unable to let go of reality. And at one point, Einstein even yelled, "God does not play dice," in an attempt to get Bohr to understand that particles have independent reality, and it's not a game of chance. But at the end of the day, Einstein lost. The experts at the time mostly agreed that Bohr was onto something. Electrons can exist in all of the possible states at once until the observation has been made. That's when the wave function collapses into one point, into a single observation. By the way, I would not blame you if you just let out an involuntary, huh?
What? We're not in reality right now. This is fictive level 1. If I'm not here, then where am I?
When I usually tell this story, I like to stop and share a quote by the renowned theoretical physicist Richard Feynman, just in case you're feeling a little lost. He said, I think I can safely say that nobody understands quantum mechanics.
Because a lot of people mangle that quote and they try to make it into a statement that you're not supposed to try to understand quantum mechanics, which is certainly not what Feynman would have argued for.
Sean says, the quote is more complicated than it seems. It's less that no one understands it and more that no one agrees on what it is.
The sense in which nobody understands quantum mechanics is that even if I personally do understand quantum mechanics, other people who are professional physicists don't agree with me about what quantum mechanics says. So as a field, even if maybe there's someone in the field who understands it, the field does not understand quantum mechanics. We don't care about understanding quantum mechanics nearly as well as we should.
For 30 years or so, scientists generally accepted Bohr and Heisenberg's Copenhagen interpretation of quantum mechanics. That is, until American physicist Hugh Everett III set out to solve Schrödinger's cat dilemma by thinking outside the box.
He realized that in the existing Copenhagen interpretation of quantum mechanics framework, the first step was to say there's the quantum system you care about, and then separately there's an observer. So if your system that you care about is the whole universe, you can't separately have an observer outside of it. So he had to rethink how to do quantum mechanics.
For my science nerds out there, this means that we cannot separate the system from the surrounding. We have to look at the entire universe. And for those of you that haven't taken my Chem 101 class, the system is Schrödinger's cat, and the surrounding is everything, well, surrounding the cat. It's the box, the table, you, me, the poison. The universe is the combination of the system and the surrounding, so the cat and everything else in the room. That Copenhagen interpretation that Sean keeps mentioning, that's when you just look at the system, the cat, by itself. But what Everett proposed is that it's better to look at the universe, everything, not just the system, the cat. Are you still with me?
So what Everett says is, well, what if I just solve the Schrödinger equation? So like the rules that you're taught by Bohr and Heisenberg are, when you make a measurement, most of the wave function disappears, and all you're left with is the one piece that you observe. And Everett just says, well, what if I erase that rule? And what happens when you open the box and look at it, according to the Schrödinger equation, is that you, Everett's big step is to say that you are a quantum system also. You're made of atoms. They obey the rules of quantum mechanics. Therefore, you obey the rules of quantum mechanics. And he said, I'm going to do it anyway. And the answer is that when you open the box and you look at it, long story short, you and the cat evolve into an entangled superposition.
Dun, 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 dun. And quantum entanglement is what gives us multiple universes. With quantum entanglement, we cannot separate the cat from the box from the observer, us. We are all linked together.
There is part of the wave function that says the cat's alive and you saw it alive. There's another part that says the cat's dead and you saw it dead. And today we have much better arguments that say once that happens and you become entangled with the rest of the world also, those two parts of the wave function evolve separately. It is as if they are separate worlds. And that's the many worlds theory. And the secret to it is not that he said, well, what if there are many worlds? The many worlds are already there in quantum mechanics. If you believe that an electron can be in a superposition, you should believe that you could be in a superposition. And then you ask, do such superpositions get created? The answer is clearly yes. And all Everett says is, chill out. Just believe it. Just accept it. Just roll with it. It actually fits the data that we have perfectly. It answers all your questions. Let's move on.
I think that's really hard for humans to do, though, especially non-scientists, because you're asking them to accept this theory that there are, I guess, millions of us running around and we can never interact with each other. And that's just, that's hard. That's hard. You're asking it like a big ask.
Way more than millions, way more than millions of you running around. They're not you any more than if you have an identical twin, that's you, right? It's a separate entity that used to be identical with you, but something happened, whether it's the zygote splitting or the universe splitting, right?
Despite how wild it may sound, Hugh Everett did not back down from his theory. In 1957, Everett wrote his doctoral dissertation proposing his many worlds interpretation of quantum mechanics. As expected, his progressive ideas were met with scorn by many other physicists. And I can't blame them. This idea is just so hard to accept. As a quick aside here, there's a really interesting documentary about Everett. Parallel Worlds, Parallel Lives. It follows his son, Mark Oliver Everett, on a mission to understand his dad's theory. If you recognize Mark's name, it's probably because he's the frontman of the rock band, The Eels.
Trouble with dreams is they don't come true, and when they do, they can catch up to you.
I don't remember knowing when he was alive that he was like a famous physicist. I don't know if I ever even knew that till after he died.
And it was Everett who really forcefully said, yeah, this is just what happens. And what I think is that it's a tragedy that the physics community has not really trained its collective brain power on thinking about these things, because there's this feeling that these different approaches have basically the same experimental predictions, and therefore we can't tell them apart. But anyway, the final lesson is that you can very well choose to disbelieve in the other worlds, but you have to tell me exactly where they go, how they disappear, how the equations need to be altered to make that happen.
Even with all that, I have to admit, I'm still not quite sold on it. Sean says the best way to understand the many worlds theory is to avoid visualizing it.
You're really going to grasp some of these wackier ideas quicker if you just give yourself up to the idea.
But I really struggle with that. I mean, my entire career is dedicated to helping people visualize chemistry. And if I can't see it, I have a hard time believing in it. On top of that, the idea of multiple versions of me is just creepy. What about you? Does it give you comfort or scare you?
Just like thinking of like an infinite universe and, the timeline of it all. Is it all happening at the same time? Is it a circle? Is it this or is it that?
I think about like all the versions of places I could live, or like places I could go, or different careers I could have taken, or just different things that I could do.
I think of the multiverse version of Eva that didn't forget the notebook at home and think about what her life is like. Or if I almost get hit by a car, I'm like, wow, there's a version of me that did get hit by a car, and that was the end of her life.
Some people really like the idea of another them because they want to be able to talk to this other version and see what their life is like.
If there is like another universe with similar people like us, or like a clone of us, whatever, like my imagination going crazy, but I feel like we will be able to learn from them, like they'll be able to learn from us, and then we might be able to help each other out.
This is Dr. Joan Tallis of SETI, the United States planet Earth. Do you read me? Is anyone out there? My name is Joan Tallis. I am the director of SETI in Mountain View, California.
Sadly, Sean says it's not like that. Contrary to what you see in movies, you cannot communicate between worlds.
I love the Hollywood versions, love the movies. But in the real world, you can't talk to each other. The different people in the different universes can't see each other. But if they can never speak to each other, it's just removing a lot of the drama from the whole operation.
It's so unsatisfying to never know if you made the right decision. What would have happened if you'd gone to the doctor sooner? Was it the right time to start a family? What if you'd worked harder? Or given yourself permission to be happier? Or what if you'd had the courage to express your feelings when it mattered the most? The truth is, we will never know, because these worlds can never collide. So even if multiverses do exist, does it really matter? We can't ask our second selves if they are happy or living with regrets. So here's what I propose. Let's just focus on being the best versions of ourselves in this world.
The only thing I do know is that we have to be kind.
Please, be kind. Especially when we don't know what's going on.
Thanks for listening to Seeking a Scientist. So this is our last episode of season 1, but I've loved hosting this podcast, and it's been an honor to interview all of these brilliant scientists and champion their work. If you like what we're trying to do here, let us know by reviewing us. What topics should we cover next season? Are there any scientists that you want us to interview? Which episode has been your favorite? What sci-fi movies need to be on our radar? Thanks so much to all of you who have written in, slid into our DMs, and just for hanging out with us this season. Seeking a Scientist is a production of KCUR Studios in Kansas City, made possible with support from the Stowers Institute for Medical Research and design help from PRX. It's hosted by me, Dr. Kate Biberdorf, aka Kate the Chemist. You can follow me on Instagram and TikTok at Kate the Chemist, or on Twitter at K8 the Chemist. This episode was produced by me, Byron Love, and Suzanne Hogan. Mackenzie Martin is our editor, Gabe Rosenberg is our digital editor, and special thanks to the staff at KCUR, Genevieve Des Marteau, and the Stowers Institute. Our original theme music is by The Coma Calling, with music from Blue Dot Sessions. You also heard songs by Olivia Newton-John and The Eels. You heard clips this episode from Spider-Man, No Way Home, Doctor Strange in the Multiverse of Madness, The Big Bang Theory, Black Mirror, Joan is Awful, Multiplicity, Avengers Infinity War, Genius, Parallel Worlds, Parallel Lives, Another Earth, Everything Everywhere All at Once, and Star Wars A New Hope. Until next time, check out our Instagram at Seeking a Scientist or Twitter at Seeking a Sci Pod to see what we're up to. Leave your comments and a review, and email me directly at kate@seekingascientist.org. Tell me who you are, why you listen. I really do want to hear it all. Until we meet again, remember,
The Force will be with you.